Hi guys, welcome back to our mathematics tutorial, and my name is Peter C. Dr. Jr., your math tutor. In this lecture, we want to solve the second example under variable separable. So we said when you have an equation or differential equation where all of the x variables can be written on one side of the equation, and the expressions with y variable can be written on one side of the equation. If you can rewrite a differential equation in such a form, it means you can apply the variable separable method to find a general solution. So we want to look at the second example. In the previous video, we did the first example. So we want to look at the second example of how we can find the general solution of this differential equation. Okay, so the first thing we need to do is we can rewrite this y prime as dy by dx. Then we say equals, now this e raised to the power x minus y can be rewritten as e raised to the power x times e raised to the power minus y plus, now this 2 that is right here, it can be the power of this x. So remember we said r a raised, let's say r ln of a equals ln of a raised to the power r. That's the rule for natural logarithm. So we can send this 2 on top of this x. So we will have e raised to the power ln of x squared, now minus y. So we can also take the we can say e raised to ln of x squared times e raised to minus y, right? Now note that e raised to the ln of a function is just equal to that function, right? So e raised to the ln of any function is equal to that function. So we can say dy now by dx is equal to e raised to the power x times e raised to the power minus y plus this is just equal to x squared e raised to the power minus y. So what we can do, we can factor out. Now if you look here carefully, you see that e raised to the power minus y, e raised to the power minus y is common, so we can like factor out e raised to the power minus y. What we will be left with, e raised to the power x plus x squared, right? So we can also cross multiply. So we cross multiply this. It means we have to multiply this, by this expression in this part 1. So it's dy equals this e raised to the power minus y times e raised to the power x plus x squared dx. So we can divide this out by, because we need all x in here and we need all y here. So we divide this out by e raised to the power minus y, e raised to the power minus y. So this and this cancel. So we'll just be left with, now this e raised to the power minus y can go up. It will be positive e raised to the power y dy equals, and then this side now is just e raised to the power x plus x squared dx. So we know that the integral of e raised to the power y is just e raised to the power y. So just e raised to the power y equals, we also know that the integral of x is just, let's say integral of e raised to the power x is e raised to the power x plus the integral of x squared. Now you add 1 to the power, which is x cubed, and you divide by the new power 3. So we attach plus arbitrary constant c. Now we want to solve for y. So we can solve for y by taking the ln on both sides, because we know that the ln of e raised to the power y is just equals to y. So we can take the ln on both sides, take the ln on this side, e raised to the power y, and also take the ln on this side, e raised to the power x plus x cubed over 3 plus arbitrary constant c. And then this is just equal to what? Ln of e raised to the power x. So if we left, we can find LCD for this expression, and yes, just want to simplify it further. So this is 1, this is 1. So 1 into 3, 3 times this is 3 e raised to the power x plus, so 3 at 1 times this is just x cubed, and then plus 3 arbitrary constancy. So y equals to the ln. Now this this expression, which is like this, like 3c, is just the same as saying c, right? Or you can leave it like that, it doesn't matter. You can stop your answer on this side. You can even stop your solution here. It doesn't matter, whatever the case might be. So we want to further, rewrite this thing as e raised to the power x plus x cubed. So this 3c, we just call it c, or over 3. So even it can be that you have the first two terms. Somebody may say, I want to rewrite my answer as ln of 3 e raised to the power x plus x cubed, or over 3. The first two terms over 3, and then plus c over 3. So we know that this c over 3 now is just equal to c, because c over 3 is the same as a constant. So you just take c. So you could say this is your final solution, or you take this to be your final solution, or you take this to be your final solution, or this to be your final solution, whatever the case might be. So that's how we find the general solution of a differential equation using variable separable. So thanks so much for watching. See you in our next video.